Hello everyone. Today I'd like to introduce you our data center products and open networking concept. When we talk about data center products, we need to understand about the current data center migration trend. Traditional chassis switches used for data centers as aggregation switches usually consist of line cards which connect to servers in the rack, and these line cards are connected through a backplane so that the traffic can flow from one line card to another line card. And the whole solution uses one or more supervisor cards which contain the CPU and the software to direct the whole solution. Now this solution traditionally is quite static, so there's an upper limit of how big you can build this chassis, and for customers it's quite expensive to acquire such a solution because they need to buy the whole box at once. So this is why we are now migrating to virtual chassis which are consisting of one new pizza box switches, and these pizza box switches have functions as leaf switch and spine switches. So the leaf switches act like the line cards, they connect to the servers in the rack, and the spine switches act as a backplane to connect all the leaf switches together. So this data plane is a full mesh network. Optionally, you can have a control plane consisting of an SDN controller and SDN applications on top of that. So this solution is more scalable and more flexible to deploy because the customer, the user, can start with a small network and enhance it, expand it, build it bigger as the customer needs it. So this leads to lower capital expense, lower operational expense, better control, agility and flexibility. Bare metal concept. From the server world, we know that traditionally we had big mainframes with hardware and software tightly integrated. And then this market has shifted towards a bare metal server market where hardware vendors just provide bare metal servers, and these bare metal servers contain a BIOS and a PXE boot application. And then the end user can choose the operating system and the application they want to use on top of it. Now the same thing happens in the switching world, where hardware vendors like EdgeCore provide bare metal switches which just contain U-boot as a BIOS and ONI as an installed system like a PXE boot system. And then the end user can choose the operating system and applications on top of that. A few words about the Clos Architecture. This is how we build these virtual chassis nowadays. So on the left hand side there's an example for a small architecture with 64 server facing ports and 4 leaf switches and 2 spine switches, and the links between the leaf switches and the spine switches are trunks of 8 links. So you have a one-to-one solution here. You have incoming 16 ports per switch for the servers and 16 ports going to the spine switches. So the oversubscription ratio is actually 1-to-1 or no oversubscription. On the right hand side you have the maximum size, which is doable with a single layer of spine switches. You can scale up to 512 ports in total. That means 16 spine switches and up to 32 leaf switches. So this solution is ideal for scale out scenarios. You start small, you grow big as you need it. You can choose, depending on the switch models you use, the oversubscription ratio which is applicable to your solution. You can have a 3-to-1, 2-to-1 or 1-to-1 oversubscription ratio. And you can build these scenarios with 1G and 10G switches, 10G and 40G, 25G and 100G. oversubscription ratios explained. In the first example, this one uses a 32 ports 40G switch, where you reserve 16 ports for the downlinks and 16 ports for the uplinks. So the ratio here is 1:1 or no oversubscription. The bandwidth between downlinks and uplinks is the same. If you use a different switch model, you use 10G switches, which have 48 ports 10G and 6 times 40G. The ratio is 2:1 because we have a combined bandwidth of 480 gigabits per second for the downlinks and 6 times 40G, which is 240 gigabits per second for the uplinks. So the ratio here is 2:1. If you use another model which has only 4 uplink ports, the ratio is 3:1 because the uplink speed is only 160 gigabits per second compared to 480 for the downlinks. So this is more applicable for use cases where you have more north-south traffic, meaning most of the communication is from internet to servers and back. On the other hand, the 1:1 oversubscription is usually used for cloud scenarios where there's a lot of east and west traffic within the data center. Now when we talk about open networking, what does it actually mean? Open networking means we have open hardware which is designed and approved by designed for and approved by OCP. We have open software, which is usually open source software, and we have optional controller and applications to direct the network. Open networking can also be called disaggregated networking. That means hardware and software are separate and the user can choose which ones they want. For open hardware, we come from standard configurations which were closed in the past, and it moves over to white box solutions where hardware and software are disaggregated, and then open designs approved by OCP, for example. On the open software, we have commercial software with open interfaces, which can be proprietary software, and then the software vendor adds some open interfaces like SNMP or netconf, and then software can hook into this. This is moving now to fully open source solutions. Software controlled infrastructure. We are talking here about SDN, software defined networking, NFV, network function virtualization, automation, analytics, and orchestration tools. The benefits of open networking are first, freedom of choice and removing of vendor lock-in. So if you compare this with vendor lock-in solutions like Cisco and Juniper sell them, you will see by separating hardware and software, you have more choice, freedom of choice. You have greater control over your infrastructure through open software platforms. So if you need additional features and you have the manpower, you can add them by yourself. Or you can work with the community and let them add the features you want for you. You have rapid innovation through a community and DevOps approach. So because of multiple end users forming a community and working together on improving the situation, improving the software, the turnaround time for innovation to happen is much shorter than if you rely on a single vendor to do everything for you. And overall, you have reduced CapEx and OpEx because opening this up and acquiring the pieces you need can be cheaper than needing to rely on a single vendor with a complex turnkey solution. This is an example of an open networking fabric. You can have multiple racks with top-of-rack switches. These top-of-rack switches could be 1G switches or 10G switches or even 40G or 100G. Then these switches connect to spine clusters or virtual chassis. So this is what I have introduced with the Clos architecture before. You have spine and leaf switches which are fully meshed and usually consist of link speeds of 10G or 40G or 100G. And then the top-of-rack switches connect to multiple of these spine clusters or virtual chassis and run a layer 3 protocol like OSPF or BGP with ECMP for load balancing. If you need a pure layer 2 network from rack to rack, you can use, for example, VXLAN tunnels to tunnel the traffic over the layer 3 fabric. You would have dedicated racks for additional network appliances like firewalls, load balancers, core routers. So these are usually called application racks. And these ones would then connect to other parts of the network. When we talk about open hardware, we talk about OCP certified hardware. So EdgeCore was the first vendor to submit a 10G switch design to OCP, and it was the first design which got approved by OCP. Then EdgeCore followed to submit 40G designs, one which was designed together with Facebook, and then two 100G designs, one with a Broadcom Tomahawk chip and the second one with a Cavium X-Client chip. We also provide an open rack switch adapter to be able to install 19-inch switches into 21-inch open rack solutions. And we are a charter member of the University of New Hampshire. They have an IOL interoperability lab, and they do open network testing open networking hardware, software, and optics and solutions to make sure everything works together. How to sell these solutions and how to identify potential customers. We need to understand that this open networking trend comes from the hyperscale cloud data centers. So these are the big tier 1 operators in the US like Google, Amazon, Facebook, and so on. And these hyperscale cloud data centers use open networking switches to connect their data centers. They use data center leaf and spine fabrics, like introduced in the slides before, and also use these boxes for data center interconnect. This then trickles down into other business areas, for example, telecom service providers, which are currently interested in cloud-based solutions like the Clos Architecture central office redesigned as a data center. They use it for network monitoring and analytics. They use it for internet exchange points, for service chaining and NFV, to connect load balancers, firewalls, IDP systems running in the cloud together. And they also use it for managed services delivery. And then finally, compute-intensive enterprises will adopt these solutions like financial services, e-commerce solutions, media, gaming, video streaming, and traditional enterprises. The use cases here are usually network monitoring and analytics, distribution centers, and PoE networks like Wi-Fi solutions and security appliances, security cameras. When we start with the big tier 1 operators, we are talking to Fortune 1000 companies who have the necessary needs to build such a big data center. So in this case, we talk with executives like CTO or CIOs, directors of infrastructure and engineering, server guys, Linux guys, and cloud guys. So these people will understand open networking concept much easier than anyone else in the company. And these are the guys who can make the decisions. For telcos, we focus on cloud service divisions and SDN solution teams because they are actively working on researching the capabilities of what these open networking architectures can do for them. So again, we talk with CTOs, CIOs, Director of Infrastructure and Engineering, server guys, Linux guys, cloud guys, and SDN guys. And for traditional enterprises and compute-intensive enterprises, We again look for Fortune 1000 companies, any enterprise that has plans for OpenStack or SDN and AV, and we talk with executives, CTO or CIO, director of infrastructure, and the head of MIS department.